Welcome back, chemistry fans. Today we are going to finish up the homework for gas laws. So this is topic 9. Oh, sorry, this is unit 9, topic 4. So we're going to jump into a myriad of different questions all together, same time here. Let's see, where did that just go? So let's share our screen so that we can get into this. I'm going to have to cut and paste the homework because I forgot to do it. So hang tight for just a second and I'll have that. A sample of gas with a mass of 33 grams occupies a volume of 208 milliliters at 29 degrees Celsius and at a pressure of 344 millimeters mercury. That's a lot of information. Find the density. So again, what we're looking at here is density equals mass over volume. We are given the mass, so we know one of the values. What we don't know is the new volume. This is the original volume. So what we're going to do is we're going to set up combined gas law. So that's PV over T equals PV over T. So my first pressure is going to be 344. We can use the pressure that is given. Don't have to convert it. The volume we can use is 208 milliliters because they're the same on both sides, so we don't have to convert it. The one thing we do have to convert, though, however, is our temperature. That must be converted. I add 273. So you must do that to both of those temperatures. So 88 plus 273 is 361 and 302 for the 29 plus 273. So we've got that value over on the right side. My pressure went to 0.88. Ooh, these are different units. So I have to multiply this atmospheres times 760 to turn it into millimeters mercury. That's one of our conversions. That's a difficult step there. 668.8. Our new volume is what we're looking for, and our new temperature is going to be the 361. So cross multiply 344 times 208 times 361 divided by 302 divided by 668.8, and I will get 127.9 as my volume. Those are in milliliters. That's okay. So we're going to take mass over volume. So I'm going to take 33 divided by that value that we just got, and we're going to end up with 0.258 grams per milliliter. Number 2, what is the vapor pressure of a mixture of air and vapor if the total pressure is this, but the dry pressure is this? So in other words, we've got vapor pressure plus the dry air equals the total. Well, the total is 30.33. The dry is 29.34. And we just subtract that and you end up with 0.99 as your PSI. Number 3. Okay, what is the partial pressure? So we've got all these mole amounts here. We're going to have to set up a mole ratio for the oxygen. So the oxygen is 0.0024 divided by, we're going to have to add up all of those pressures together. So I got 0.0024 plus 0.0002 plus 0.006, and I get 0.0086 as the total. This is going to give me my mole ratio. That's not my answer, but that is a mole ratio. That tells me the percentage, essentially, of what I need to multiply the partial pressure or the total pressure by. So 0.279, the total pressure, it says, is 4.5 atmospheres. So it makes up 28% roughly. And I get 1.26 atmospheres for number 3. Number 4, molecule travels at about 505 meters per second at room temperature. Find the velocity of helium at that same temperature. So Graham's law is velocity ratio. So I've got N2 versus helium, but it's the inverse of their molar masses. So helium would go on top and nitrogen would go on bottom. So let's substitute in what we got. Velocity of nitrogen is 505. I'm looking for this value. Square root of the mass of helium over the mass of nitrogen. So 4 divided by 28, find the square root button on your calculator, and you get that is equal to 0.37796. So we're going to cross multiply now. 505 divided by 0.3779. And we get very, very fast, 1,336 meters per second. And that makes sense. It should be faster. It's a smaller molecule. Speaking of which, we got to figure out which one of these two is faster. All you got to do is add them up. Sulfur weighs 32. The oxygens each weigh 16. That's a total of 64. CO3, carbon weighs 12. Each of the oxygens weighs 16. So I've got 48 plus 12, that's 60, very close, but the carbon dioxide will be faster. All right, this is everything that I wish to share with you about your homework. I hope that this starts to make sense with you. Practice some more. Talk to you soon. Take care. Bye-bye.